Hello, good evening, and welcome to today's class. In today's class, we'll be talking about loops. But before we dive in, I want you to take a minute, pause. If you have not subscribed to this channel, subscribe to get related information. I believe at this point, you've all subscribed to this channel, so we can continue. Today we are talking about loops. When we talk about loops, what is a loop? A loop is basically being able to repeat certain lines of code, a line or a number of lines of code a number of times, or until a condition has been met. In C++, when we want to repeat lines of code, there are three ways of going about that: by using the while loop, the do loop, or the for loop. The while loop is the most simplest way of trying to iterate your code or repeat your code. Let us see how somebody can use a while loop. So, like you can see, I have started a new project. I'm calling it loops. So if I want to start a while loop, let's say initially let's start from the known to the unknown. The known, what do we know? We know how to declare a variable. So let's say we want to declare a variable called n. So int n is equal to what? Let's say 10, right? Then we know how to display a number. We display a number by using what? The cout command. So cout n, and then because we want to move, or because we want to display the numbers separated by commas, so we want to display the numbers from 10 to 1 separated by commas. So once we display the number, we want to display the comma. All right. So these two lines of code we are very familiar with them. Now, the question is, we have a variable n, which contains 10. So we want to display n. So this will display 10. But after displaying 10, we want to reduce what is inside n by 1 and then display it again. That is how we are able to display from 10 to 1. So how do we do that? It means that it is this same display code that we want to repeat a number of times. So let us start by using the while loop. In using the while loop, you type the keyword while, and then you bring an opening and closing parenthesis and put in your expression. The expression is the condition for which, if it is true, the repetition should happen. So it means that whatever you are going to put in the bracket, if it is false, then the repetition will not happen. So we say that whilst n is greater than 0, we want you to display what is inside n. And then again, once you do this, remember to put all the codes that you want to repeat inside an opening and then a closing curly brace. In our case, it is only one line of code, but this can be 100 lines of code, and you still have to wrap them in between the opening curly brace and then the closing curly brace. But what we would realize is that if we leave it at this, then n would always, or our code would always display 10, because n is equal to 10. So anytime we repeat, we want to reduce what is inside n by 1. So we'll go ahead and say minus n, or this is the same as n is equal to n minus 1. Let's see how this would work. So looking at the results of our code, we realize that it starts from 1 and then stops at 1. It starts from 10, sorry, and stops at 1. Alright, so we can go over this to summarize it and say that when you want to repeat some lines of code, or whenever you want to repeat some code in C++, there are 3 ways that you can go about it. You can use a while loop, you can use the do loop, or you can use the for loop. In the while loop, what we are saying is that you start with the keyword while, followed by an opening and closing parenthesis, and then in between those parentheses you put your expression. The expression is what if it evaluates to true, then the repetition should happen. So the condition, which if it is true, the condition should happen. So in our case, we are saying that if n is greater than 0, and then it should repeat. And then the action, whatever you want happen if the condition is true, will be put between the opening curly brace and then the closing curly brace. I hope it is clear. Alright, so let's move on to the do loop. In the do loop, it's similar to the while loop, except that instead of starting your loop with the statement while, you start with the statement do, and then after do, you are going to open and close your curly brace, and then now bring your condition after the closing curly brace. So you say you want this action to be repeated if the condition here, n is greater than 0, is true. Meaning that as long as n is greater than 0, then the condition here, or the action, that is what is in between this curly brace and that curly brace, would be repeated. One thing you should note is that because the condition is evaluated after the action, in a do statement, your action will be executed at least once. Meaning that once I want to execute this do action, whatever is in here would be executed at least once before your compiler will test to see if the condition is true or false. If it is true, it will repeat again. If it is not, it will stop. So meaning that in the first instance, whether it is true or false, whatever is here would be executed at least once. So in summary, you see that we are getting similar results to what we had when we ran with the while loop. So in summary, what we can say is that the do loop behaves similar to the while loop. The only difference is that in the while loop, the condition is evaluated before the action is taken, but in the do loop, the condition is evaluated after the action has been taken. Alright, so let's move on and look at the for loop. When you want to use the for loop is constructed in this way. So you see, you start with the keyword for, and then you open and then close the bracket. But inside that bracket, you would have a first statement which we refer to as the initialization. That is basically you declaring the variable that you would use to control your count. So for instance, in the previous example, we used n. Instead of declaring n outside of the loop, like we did in the while, in the case of the while and the do while, we are going to declare n inside of the bracket for, or in the case of the for loop. And then the condition, which is similar to what we saw in the while loop, is the next statement that would come. And then remember, in the while loop, we had what we call the counter being increased or decreased to be able to ensure that our condition does not remain true forever. You understand? So you saw that we wrote something like minus n, where I explained that it's the same as n is equal to n minus 1. This is to ensure that n does not remain 10, but anytime we loop, n will be reduced by 1, and at a point the condition will be true and then we will stop. Or sorry, the condition will be false and then we'll stop. So that statement would also follow. So in this bracket, we will not have only one statement like we did, but 3 instead. So let's assume that we want to write a for statement for the previous example. What we are going to write is, let me first delete this and say write for. Then we open and close our bracket. So we'll start with the declaration. So for int n should be equal to 10. This is a statement, so we end it with a semicolon. Then we continue with our condition. Our condition said that whilst n is greater than 0. This is also another complete statement. And then we continue with our increment or decrement operator. So we say that this time we want it to reduce. Anytime the repetition happens, we want you to reduce it by 1. And then once that happens, what is the action that we want to happen? The action we want to happen is that we want to output the value of n, right? We want to output the value of n and then followed by a comma. So let's run this and see what we get. So you see that we are getting similar results to what we had when we used the while and then the do loop. So you see that it doesn't matter which type of loop you will use, the results is almost always the same. But let's make this even more exciting, and let's say that we are now going to change our application and say that we want our user to produce and to give us an input, and we want to display numbers from, let's say, from 1 to that particular number. So what I mean is that let's change this app that we have developed and say that now the new specification for the app that we want to write is that we want our user to give us a number, and then we will display from 1 to that number. Let's try it and see. Alright, so what we can see here is that I took the liberty of adding these few lines of code, which I know you already understand. The first one is that I declared a variable called number, and then I prompted my user to enter a number, and then whatever the user enters is received into the variable number. After receiving that into the variable number, I'm using the for loop and saying that I want my control counter, which is n, should start from 1 until n is less or equal to number. Anytime that it takes action, it should increase it by 1. What action do I want it to take? I want it to display the value of n. So meaning that starting from 1 till whatever number the user entered, I would display the new value and then increase it by 1. Let us run this and see what we get. So once we run this, let me enter 20. After entering 20, I hit enter, and then you realize that it displays from 1 to 20, just like we intended it to work. And so this is a typical example of how to use the for loop. But we can make this program really more exciting, right? How do we make it more exciting? Let us assume that now we want to take it a step further, and we want to make sure that whatever number the user gives to us, we want to check if the number is a prime number or not. Just an example. So we want to check to see if the number that the user has entered is a prime number or not. So at this point, you need to understand what a prime number is. If you don't understand what a prime number is, take some break, read more about it. But in short, a prime number is any whole number that has 1 and itself as the only two factors. So any whole number greater than 1 and then the two factors are 1 and then itself. I hope it's clear. Alright, so as you can see on your screens, I've taken the liberty of adding the codes for us to see if we can make our program that we started more exciting. How do we make it more exciting? By ensuring that the number that was entered by the user will determine whether it is a prime number or not. And we've already explained what a prime number is. We said a prime number is a whole number that has 1 in itself as its only two possible factors. Meaning that if you want to determine what a prime number is, then you can start from 2 and then start dividing the number by every other number and see if there is a number that goes into it aside 1 and itself. If there is ever a number in between 2 and itself that goes into it, then that number is not a prime number. But to even make your algorithm more efficient, you don't have to travel from 2 to the number, assuming that the number is a very large number. What you can do is that you can start from 2 to the square root of the number. If you travel from 2 to the square root of the number and you don't find any number in between that range that is able to divide it, then it is possible that all the numbers after that would not be able to divide that, and so it becomes what? A prime number. And so that is the method that I used. So what I started with is I started off by declaring number, which I did, and then I declared a boolean called is prime, which I will use to keep track whether I have found a prime number or not. Then I prompted my user in this line for the user to enter a number. Whatever the user entered, I received here. Then I came here. This is where I started using my loop. So I'm saying that my loop should start counting from 2 because prime numbers, any number 1 and below is not a prime number. So I started counting from 2 to the square root of the number that was entered by the user, and within that range I tried to divide the number by the new value of j, the number supplied by the user by the new value of j. And if there is ever a time where it is able to divide it without a remainder, remember that we are using a modulo here, so if it is able to divide it without a remainder, then it is not a prime number, and so I'll change the value of is prime to false, telling me that, oh, this number is not a prime number, and I'll immediately leave the loop. So that is what this break means. Break means that you should immediately what? Stop the loop. And so I would leave the loop, and then once I leave the loop, I'll come and check if is prime, which is the boolean variable that I'm using to keep track of whether I found a prime number or not. If it is true, I would say that then that number is a prime number. If it is false, then that number is not a prime number. So we can go ahead and test our code and see if we'll get the value we are looking for. So let me start by entering a number like 3, which we know is a prime number, and then let me hit enter, and our algorithm is able to tell us that this 3 is a prime number. So again, I would enter a different number, let's say 50, and then I will hit enter, and then it immediately tells me that 50 is not a prime number. So you can play around with different numbers and see what you get. Try to understand the code and try to do some of the work on your own and see if whatever we are doing makes sense or it doesn't. Leave any questions that you may have in the comment below, and I will try as much as possible to respond to them. If you have any additions or any comments that you have, please don't hesitate. And also remember, to keep us motivated and to keep us pushing, I would need you to subscribe to this channel. So please take time and subscribe to this channel. Thank you very much.